Okay, one more video with kind of extra credit for those pre-AP folks who really want to get a little bit more information about where these sets of numbers come from, these subsets of numbers come from, and why we use them. Um, natural numbers, right? Natural numbers, the ones you see out in nature. These are the ones people started counting with 100,000 years ago. I don't know when they first started, but people look around and say, "Hey, I got 3 elk. How many did you get?" "I got 4 elk." Right? These are the things you can count. They're the first kinds of numbers that people learned, and they're the first numbers you learn when you're a little kid. Right? You start counting your fingers. So we're going to start with the natural numbers, which I'll also call the whole numbers because there's not a lot of difference, right? What's the difference between a whole number and a natural number? Right? A whole can be zero, right? Zero is a whole number, zero is not a natural number. That's the only difference. Okay, let's think about my operations. Now remember, the operations in math are the things you do with numbers. It's like an operation. You go to the hospital, the doctors do things with your body. Okay, anyway, operations are we do with numbers in the number hospital, right? So we can add numbers, multiply numbers, divide numbers, subtract numbers, raise numbers to exponents. Those are our operations, and you remember them because we use them in the order of operations, right? So whole numbers. Let's try adding two whole numbers together. Okay. If you take, let's take 3 chairs, and I add that to 2 chairs. What do you get? Well, you should get 5 chairs, right? Okay. So this is true for all whole numbers. A whole number plus another whole number gives you another whole number, right? We call this, the technical term we call it is that the whole numbers, the set of whole numbers, is closed for the operation of addition. Okay, we call that closed. It means it's kind of like a store being closed, right? It means you could add anything together, anything together. You could add 1,000,000 and 3,000,000, and you'll still get another whole number. Okay, you might be thinking, well, of course that's true, right? But let's take a look at subtraction. Actually, you know what? It's also closed for multiplication. I'll let you think about that one. But guess what multiplication is? Multiplication is just adding something over and over again, right? So of course it's closed for multiplication as well. All right, let's talk about subtraction now. Now it's true that if I have 5 chairs and we're playing musical chairs, and I take one away, I still have a whole number of chairs, right? I still have 4 chairs. But sometimes sometimes the whole numbers as a set is not closed for subtraction. For example, we're learning about this right now with uh, negative numbers, right? What if I have, what if I want to do 5 chairs minus 8 chairs? Hmm? Ah, you can't do it. There's no answer within the whole numbers, is there? I don't know why you want chairs, but let's change that to something that you can actually have. Let's do, here's a good one. Here's money, right? People do this all the time. You have $5 and you spend $8, thanks to that credit card, right? You spend $8, you actually spend more than you have, which is possible now thanks to that plastic. Mm-hmm. And you run up a bill, right? You don't have a whole number of dollars left. You have a negative number, which is an integer, right? So the reason why, one of the reasons why we came up with the integers is to accommodate subtraction, right? And actually, integers came about with money. People were buying and selling stuff, and they realized that hey, we could actually have a debt. We could have negative money. If I have $5, I could spend $8, but I would put myself in the debt of whoever I bought that from for $3, right? That would be negative $3. In other words, I owe you $3. Okay, so the integers now are they're closed for addition, and they're also closed for subtraction. Okay, right? So you can add any two integers together and get another integer. You can subtract any two integers, one from another one, you'll get another integer. How about multiplication? Yeah, multiplication is the same as addition, right? So you can multiply any two integers together and get another integer. It's true. Okay. How about division? Could I take any two integers and divide them and still get another integer? Well, if I did 6 divided by -2, that would give me an integer, -3. But if I did 5 divided by 3, that's not an integer anymore. Right? 5/3, not an integer anymore. So we had to come up with a new kind of number called the rational number. And you'll remember from the first video about how I define a rational number. A rational number is a number you can write as a fraction. It's a number you get after dividing two things. So because we couldn't divide integers and be within a closed set, we had to come up with a new set of numbers, the rational numbers. And the rational numbers, they're basically defined as closed for the operation of division. Okay? So now you can take any two integers with the sole exception of 0, I'll point that out in a minute, and you can divide them and you will get another rational number. You can take any two rational numbers, divide them, and get another rational number, except for 0, right? You could take any two rational numbers. You could take 0.0824 divided by 17/5. Boy, that's an ugly one. I don't know what it is. I'd have to pull on my calculator to see what it is. But whatever you would get, it would be a rational number. In fact, maybe I'll pull it up right now. I can keep it up here. Let's see, 0.0824 divided by 17/5. Whoa, it's an ugly one. Yeah, it's very ugly. It's an ugly number. 0.0242352941177647058. Wait, it'll start repeating here pretty soon. I'm looking for, because we covered in classes already, we talked about repeating and terminating. It's got to either, because we know it's rational. This number's got to either repeat or terminate at some point. 235. Oh wait, there it is. 235. 235. 29. Oh yeah, there it is. Okay, start repeating at the 235. Whew. Boy, that's an ugly number. No offense, number, but you're kind of ugly. Holy smokes! Look at that number. You see that? That's insane. But it is rational. That's kind of funny, right? Because irrational, rational means you're not sane. Anyway, it's insane, but it's rational. Okay. Whew. That's a rational number. So any two rational numbers, when you divide one by the other one, it gives you another rational number. I said it with the exception of 0, and that's because in mathematics, you cannot divide by 0. That is a big, you can't do it. You can never, ever, 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 ever divide by 0. Why not? Do I want to get into that right now? Not really. No, sorry. I don't. Here's the thing. You could. How many zeros does it take? If you had to add up zeros, multiply them together, how many will it take to get to 8? You can't do it, right? You can never add up enough zeros to get to 8. 0 plus 0 plus 0 plus 0 plus 0. You could add a billion zeros together. You could add a trillion zeros together. You could add an infinite number of zeros together, and you'll never ever get 8. So there are no zeros in 8. You can't divide 8 by 0. You can't divide anything by 0. I don't want to talk about right now, but you can't even divide 0 by 0. All right? So, yeah, rational numbers are closed for division with the exception of, but not 0. Okay? And that's how it goes. Later on, we'll see people want to do other operations. Maybe they don't want to just do addition and multiplication, subtraction, and division. Maybe they want to do things like square roots. Okay? Square roots means finding a number that times itself equals that number. So 16 has a square root of 4. 4 times 4 is 16, right? 4 squared is 16 square root of 16 is 4. What if I want to find the square root of 15? Well, it's not 3, that'd be 9. 3 times 3 is 9. It's not 16, that'd be 4. It's some number between 3 and 4. Because that's a new operation, it's not division, it's just square rooting. We have to come up with a new type of number. We can't use rational, and that's why we come up with irrational. But we won't even talk about that this year. We won't get into that until the 8th grade to start talking about irrational. We'll see a couple numbers that are irrational, like pi, I mentioned that before, but we won't talk about irrational numbers really. But just know that there are some numbers that are not rational. Okay. And then as you get to more and more math, you want to do even crazier things with numbers, even crazier than taking square roots. I'm talking really crazy stuff. I won't even mention it. You have to come up with new kinds of numbers. Right? Every time you want to do something crazy you can't do with a kind of number you have already, mathematicians do that. They invent a whole new kind of number, and they pretty much invent it. Right? So they invent numbers like, just throw out a couple of words. They invent imaginary numbers. They invent transcendental numbers. Actually, wait, that's not transfinite numbers. They invent surreal numbers. All these weird things you'll never see. You might see this in high school. You'll never see those unless you become a mathematician, right? But that's a cool thing. Anytime you have a new operation, right? Start with the easiest numbers. Then you want to do an operation like subtraction. Hey, let's invent a new kind of number, integers. Wait, I want to divide. Oh, well, we can't divide with integers. Let's invent a new one, rational numbers, right? So that's how it works. All right, that's it for this video. I'm going to go home and have some lunch, have some dinner. I'm tired. Here we go.